Hey everyone, in this mini lecture we're going to take a look at factoring trinomials where the leading coefficient is not a 1. Not a 1. So we have trinomials in the form of ax squared plus bx plus c. And we're specifically looking at this coefficient in front of the x squared. This is known as the leading coefficient because it's seen first reading from left to right. Previously, you have been dealing with trinomials where the leading coefficient was a 1, an invisible 1, where there was nothing in front of the x squared. So that would be a more simple method, maybe the product sum method, for you to work through. However, when the leading coefficient is not a 1, it could be a 2, a -5, it could be a 10, a 3, then we have to perform other techniques such as the AC/grouping method. There's a trial and error method and a couple of other methods out there. What we're going to do today is the AC/grouping method. So here's our example. If you have 3p to the second power minus 2p minus 5. Okay, so looking at this, I see the leading coefficient is a 3. It's not a 1, so I'm going to perform this AC/grouping method. So the first thing we do is multiply our a and our c. The a is 3, the c is -5. So 3 times -5 is -15. The next thing I'm going to do is list the possible factors for 15. I know 1 and 15 are factors, 3 and 5, and I believe that's it. Now I must say to myself, I know 1 times 5 makes 15 and 3 times 5 makes 15. But if I add or subtract those two, will I get that middle value of -2? -2 by adding or subtracting. So I'm going to give it a try. Place a 1 and a 15 in and say to myself, if I add 1 and 15, will I get -2? Or if I subtract 1 and 15, will I get -2? No. How about 3 and 5? If I add them, will I get a -2? Or subtract them, will I get a -2? Yeah, sure. If I do the addition subtraction with a -5 and a +3, that would get me a -2. So that's what I'm going to work with, +3 and -5. So in my next step, I'm going to rewrite the trinomial. Well, at least rewrite the first term, the 3p squared, and rewrite the last term, the -5. Now the middle term is what I'm going to rewrite and just make it look a little different. I will not write the -2p. I'm going to rewrite it using the +3, and don't forget the p, and the -5 that I've just found. So +3p and -5 is used to replace that -2p. So now I have 4 terms. So now I can go ahead and perform grouping. So it looks like I'm going to group together 3p squared and 3p and -5p and -5, right? Because it looks like the 3p squared and 3p have a 3 in common as well as a p. The -5p and the -5 have a 5 in common. So next, what I'm going to do is go ahead and do each part separately, factor by GCF. Well, the GCF of 3p squared and 3p is 3p, right? They both have a 3 in common and a p in common. Then you just divide. 3p goes into 3p squared, p times 3p goes into 3p once, right? And then I'm going to do the same thing to this right side. The GCF of -5p and -5 is -5. They have a 5 in common. The leading coefficient is negative, so my GCF is negative. And then -5 goes into -5p, p times. -5 goes into -5, positive 1 times. So I know I'm on the right track with this method because I see the p plus 1, whatever it is that you have in the parentheses, I see that repeating itself. If I don't see it repeating itself, then I know I did something wrong, either in the grouping step or in the factoring step. However, I see that repeating, so I know I'm on the right track. The one that repeats, we just write over one time as our new GCF of the entire expression. And then those on the outside, the 3p and the minus 5, we take that and just push it together in its own set of parentheses. And now this is my factorization. P plus 1 times 3p minus 5. If you wanted to, you could flip them. You could write 3p minus 5 times p plus 1. Alright, so in our next example, we have 3x squared minus 8x plus 4. I see the leading coefficient is not a 1, so that tells me let's go ahead and perform our AC slash grouping method. So A times the C, so 3 times 4, positive 3 times positive 4 gets us 12. And now I'm just going to write all the factors of 12 that I know. I know 1 and 12, 2 and 6, 3 and 4, that's 5, no, 6 and 2, but I already have 2 and 6, 7, 8, 9, 10, 11, 12, and 1, but I already have 1 and 12. So now I'm going to say to myself, I know all of those make up 12, but can any of them get me a negative 8? Negative 8. Well, I know 1 and 12 added or subtracted can't get me a negative 8. 3 and 4, if I add or subtract them, cannot get me a negative 8. But 6 and 2, if I add them together, a negative 6 and a negative 2, I can get a negative 8. So that's what I'm going to use to rewrite that middle term. So again, we have 3x squared, and I write the n term, the constant, the 4, and I'm going to rewrite the negative 8x with the numbers I've just found. Negative 6, and don't forget the x, negative 2, don't forget the x. And now I'm just going to group them. It just so happens that the groupings are right next to each other, but if they weren't, I would just physically pick a term up and put it next to another term, like in this next step, 3x squared. It's already next to the negative 6x, which is fine, so I just write it over. But if it weren't, if it were at the end, I would physically pick it up. Don't change signs or anything like that, but physically pick it up and put it next to whatever it's similar to. And in this problem, they just all happen to be next to each other. Okay, so now I factor by GCF. The GCF is 3x. It goes into 3x squared x times, and it goes into negative 6x negative 2 times. The GCF of 2x and 4, they both have a 2 in common. The leading coefficient is a negative, so our GCF has to be negative. So negative 2 goes into negative 2x x times, and negative 2 goes into positive 4 negative 2 times. I see the repetition of what's in the parentheses, so I know I'm on the right track. So I write that, what repeats itself, over once as the GCF of the entire expression. And then the ones on the outside, I'm going to take those and push those together in their own set of parentheses. And my factorization is x minus 2 times 3x minus 2. In this next problem, we have 5x squared plus 19x plus 12. The leading coefficient is a 5. It is not a 1. So I'm going to perform this AC slash grouping method. So I'm going to need to multiply the A value, which is the 5, and the C, which is the 12. Positive 5 times positive 12. That gets me a 60. So here I'm just going to run through all the different factors. And as you get better with this, you may not have to even write them down. You can just go ahead in your mind, run through the factors and see which factors add up to 19. But for now, 1 and 60, multiply to get 60, 2 and 30, 3 and 20, 4 and 15, 4 times 15 makes 60. Let's see, 5 and 12 makes 60. 6 and 10. Let's see, 7, 8, 9, 10. 10 and 6, but I have 6 and 10. 12 and 5. 15 and 4. And I think everything else will just be repeated as I go higher and higher, closer and closer to 60. So these are all the factors. So I'm thinking to myself, which one of these, when I add or subtract, will get me a positive 19? Positive 19. So 1 and 60 don't get me a positive 19, right? That's like 59 or 61. So looking through those, 3 and 20 would make 17 or 23. How about these two, 4 and 15? 4 and 15. So I'm thinking a positive 4 and a positive 15 will get a 19, positive 19. So I rewrite my trinomial. The 5x squared, the leading term stays, the last term stays, the 12. However, that middle term is rewritten with what I just found. Positive 4, and don't forget the variable, and a positive 15, and don't forget the variable. So here's a case where I'm going to now do the grouping, but now I'm going to physically pick up my 15x and put it next to the 5x squared because I think they go together, and the 4x with the 12x, right, because I think they go together. You don't necessarily have to group it like I did. The 5x squared and the 4x, they actually do go together because they have an x in common. And the 15x and the 12, they still go together because they have a 3 in common. But I just wanted to put them together with the 5x squared and 15. I like it like that. But as long as they are legitimately grouped together with something because they have something in common, then it'll still work out. It would still work out for you. All right, so now I'm going to do factoring by grouping. The GCF of 5x squared and 15x is 5x. And now I divide the 5x into each one of those. Into 5x squared is x. 5x into 15x is 3. The GCF of 4x and 12 is 4. 4 goes into 4x x times, and 4 goes into 12 3 times. I see what's repeating, which is the x plus 3. So I put that as my GCF of the entire expression. And what's on the outside? The 5x plus 4, I put in their own parentheses. And there we have the factorization being x plus 3 times the quantity of x, 5x plus 4. So here's our final example, 9x squared plus 66x plus 21. I see the leading coefficient is a 9. And remember one thing though, no matter what method that you're doing to solve your problem, to factor your expression, you're always going to look for a GCF first and foremost. That is the first step in factoring. Look for a GCF. The other problems previously didn't have one. However, this problem does. The GCF of 9, 66, and 21 is 3. So 3 goes into 9x squared, 3x squared times. 3 goes into 66x, 22x times. And 3 goes into 21, 7 times. And now we're going to factor what's in the parentheses using our AC/grouping method. So our A is still the leading coefficient, which is not a 1, and our C is 7. So we have 3 times 7, positive 3 times positive 7, make 21. All right, so different factors of 21 will be, of course, 1 and 21, 3 and 7. Let's see, 7 and 3, we have 3 and 7. I think that's it. So we have to say to ourselves, which of these two factors, if we add or subtract, will get us a positive 22? Well, definitely not 7 and 3, right? But 21 and 1, 1 and 21. If we add or subtract them, will get us a 22. the two positive signs in front. So we're going to rewrite, don't forget your GCF, and we have a 3x, and then we're going to have a positive 7, right? And then in between, we're going to use the plus 1x plus 21x. All right, and now we have to group. So it looks like there's different ways we can group. We can group the 3x and the 1x because they both have x's in common, and the 21x and the 7 because they have 7's in common. We could group many different ways if we want. We can physically pick up one of the other terms and put it next to another, and it'll still work out, it looks like. So I'm just going to keep it like it is, the 3x, and then the 1x, and then the 21x, and the 7. So once we do this, factoring by GCF now. So the GCF of 3x and 1x is x, and it goes into 3x 3 times, and it goes into, 3x squared. It should be, it goes into 3x squared 3x times, and then x goes into 1x, or it goes into 1x is really just x, right? So x goes into itself just once. And on the other side, the GCF of 21 and 7 is 7. Right, it goes into 21x 3x times. It goes into itself once. So remember, if you see this repeating pattern, you know you're on the right track. So that is your GCF of the entire expression. It gets put into parentheses just once, and the things on the outside, the x and the 7, we move those into their own set of parentheses. And then don't forget to bring down that original GCF of 3, right? You can't just throw it away. It just follows you down in the problem. So our factorization is 3 times the quantity of 3x plus 1 times the quantity of x plus 7.